Hello, welcome to Ohio DOT's training for its Multimodal Design Guide, or the MDG. This video is the 7th module of a 13-part training series that will span the entirety of the guide. In this video, we'll continue our discussion of Chapter 6, On-Road Bicycle Facilities, with a focus on the topics of intersections and bike crossings. This module will discuss the evaluation of uncontrolled roadway approaches and countermeasures, and then move through the topic of geometric bikeway design. For design guidance on signals, please see our Chapter 8 training. Also note that while the intersections and treatments discussed in this chapter are universal, Chapter 9 specifically discusses the nuances of designing for complex intersections and interchange treatments in greater detail. When bicyclists are at a stop or yield-controlled intersection, and motorists on the intersecting roadway are uncontrolled, the intersection should be evaluated to determine how many crossing opportunities are available to the bicyclist. This may be done using a gap study as further discussed in the Highway Capacity Manual, or HCM. If sufficient crossing opportunities are not available, bicyclists are likely to accept smaller gaps or avoid the bikeway entirely due to the uncomfortable or inconvenient crossing conditions. As shown on this slide, the guide discusses the recommended number of bicycle crossing opportunities per hour that should be available at uncontrolled crossings and methodologies for evaluating crossing opportunities. At locations where gaps do not provide the recommended minimum number of crossing opportunities, engineering countermeasures to increase crossing opportunities should be considered. As shown on this slide, the guide provides a table to select countermeasures based on roadway characteristics. The countermeasures are split into 3 tiers. Tier 1 begins with markings and signing. Tier 2 involves changing the design of the street to create conditions that create crossing opportunities. And Tier 3 involves signalization or grade separation. For roadways operating over 30 miles an hour, it may be necessary for a traffic control device to display a red signal to require motorists to stop for crossing bicyclists and for pedestrians at these locations where gaps in traffic are insufficient. The MDG further discusses that in many contexts, the installation of multiple countermeasures may improve yielding and safety outcomes. Section 6.5 of the guide discusses the design of bikeways at intersections and bike crossings. The preferred design treatment at every intersection and crossing should meet the listed design principles. First, designers need to minimize a bicyclist's exposure to conflicts. It is preferred that a bikeway and any physical separation provided along a bikeway be provided and maintained up to the intersection. In some instances, a greater degree of separation from motorists may be needed and can be accomplished by transitioning to a different facility type or through signalization. If conflict points cannot be eliminated, intersection designs should minimize the speed differential between users at the locations where these traffic movements intersect. Reducing speeds at conflict points, particularly the speeds of motor vehicles, may allow all users more time to react to and avoid a crash. And reducing speeds further can reduce the severity of potential injury if a crash does occur. Treatments for reducing speeds and improving safety at conflict points are provided in subsequent sections of the MDG based on the specific bikeway type and roadway configurations. Chapter 7 also provides design guidance for the various traffic calming treatments and intersection designs that help to minimize speeds of motorists at conflict points. Designers must understand that adequate sight distance between bicyclists, motorists, and pedestrians approaching an intersection or a crossing is needed to give everyone an opportunity to perceive and avoid potential conflicts. Sight distances at intersections can be preserved by using curb extensions or limiting parking near intersections. Flex posts or bicycle parking corrals can also be used in the street approaching these locations to prevent unintended sight obstructions. As previously discussed in section 3.5 of the MDG, that's where we define sight distance requirements for different intersection scenarios. Intersection design should provide bicyclists, pedestrians, and motorists with visual cues that both clearly establish which user or users have the right of way and consistently communicate expected yielding behavior. This is often accomplished through the use of traffic control devices to communicate the right-of-way priority. These traffic control devices may include marked pedestrian crossings on shared use paths, marked bicycle crossings or lane extensions at driveways and intersections, regulatory or warning signs for motorists and bicyclists at crossings, merge locations, or other locations where conflicts may occur, and signalization. Regulatory and warning signs will depend on the type of bikeway, the lane configuration, and other roadway characteristics. Different intersection layout scenarios are discussed in the subsequent sections of the guide. Intersections also often serve as the place where bicyclists make transitions from one bike facility to another. Transitions between bikeways should be intuitive for all users of the intersection. For example, it is important to provide a clear and direct path for pedestrians crossing a bicycle facility to reduce the likelihood that pedestrians will use the bike facility as their walkway. Where possible, transitions should also reduce delays for users. For example, in the image shown, a bike box is provided for bicyclists who arrive at the intersection on red, while the bike lane extends through the far side of the intersection for bicyclists who arrive on green. Several examples for bikeway transitions are discussed in earlier sections of the guide. Finally, intersections and crossings must be designed in accordance with accessibility guidelines. Attention should be given to ensuring people with limited or no vision are given sufficient cues at intersections or pedestrian crossings to guide users to intended crossing areas and discourage them from unintentionally moving into the street or into the bikeway. As noted previously, bicycle crossing pavement markings are important communication tools. They do so by delineating a preferred path for people bicycling through the intersection, especially when crossing wide or complex intersections. They also improve the legibility of the bike crossing to roadway users. And finally, where motorists must merge or turn across the path of a bicyclist, these markings encourage motorist yielding behavior by communicating where bicyclists should be expected. Another important marking for intersections is the two-stage bicycle turn box. These markings designate an area of an intersection intended to provide bicyclists a place to wait for traffic to clear before proceeding in a different direction of travel. To use the two-stage bike box, bicyclists traverse the intersection within the bike lane, then they stop within the turn box and reorient themselves to the cross street, and then they wait for the signal to cross that cross street. Two-stage turn boxes eliminate the need for bicyclists to merge across motor vehicle travel lanes to make turns, which can be particularly stressful for the interested but concerned bicyclist. The guide provides direction on when two-stage turn boxes should be used and provides guidance on their placement on the roadway. Finally, the guide includes conventional bike boxes, which are designated areas on the approach to a signalized intersection. They consist of an advanced stop line and a bicycle symbol. Bike boxes can be used to mitigate conflicts between through bicyclists and right-turning motorists. They can reduce conflicts between motorists and bicyclists at the beginning of a green phase, and they can provide additional queuing space for bicyclists. Again, the MDG discusses the application of this treatment in detail. Each of the bicycle markings discussed may be supplemented with green-colored pavement. The use of green-colored pavement is encouraged at specific types of conflicts to improve the legibility of the bike crossing or bike waiting area for all roadway users. Shown on this slide is a table from the MDG that summarizes when lane extension markings and optional supplemental green-colored pavement are recommended. Next, we'll discuss specific intersection treatments for different bikeway types. For separated bike lanes and side paths, a protected intersection is the preferred treatment. Protected intersections maintain bicyclist separation up to the intersection for both separated bike lanes or side paths. Corner islands, shown with a number 1 on this slide, are the vertical features that allow this separation to be maintained. The design principle of a protected intersection may be used at signalized or unsignalized intersections, as well as at driveways. Where the conditions at an intersection are constrained, the guide provides a list of steps that designers should take to adjust the roadway to provide a protected intersection if possible, but also provides alternative strategies if a protected intersection cannot be accommodated. Where protected intersections are not viable, or where separated signal phasing cannot be provided between a right-turning motorist and bicyclists, a mixing zone option, like those shown on the right-hand side of this slide, may be considered for separated bike lanes at intersections. Mixing zones create a defined merge point for a motorist to yield and cross paths with a bicyclist in advance of an intersection. Mixing zones require removal of the physical separation between a separated bike lane and the general purpose lane along the intersection approach, and are therefore generally only appropriate as an interim or retrofit solution, or in situations where right-of-way constraints make it infeasible to provide a protected intersection. For bicycle lanes at intersection approaches, designers should provide a continuous and direct route through any intersection, driveway, or alley to ensure that it is legible to all roadway users. Designers should minimize the length of conflict areas between bicyclists and motor vehicles or eliminate them if possible. To minimize the potential for conflicts, designers should adhere to the principles listed on the slide. Each of the subsections in the guide follow these principles of using markings and signing and designs that communicate yielding location, keeping merging and weaving areas short in length and with low speed, and marking crossings to reinforce space where bicyclists are expected. Next, we'll briefly go over some of the general and intersection-specific guidance that you will find in section 6.5.3 of the MDG. For pavement markings, where motor vehicles are permitted to enter a bike lane to prepare for a turn, a crossing, or a merging maneuver, the bike lane lines may be solid or dotted on the approach to and within the intersection. The choice between a solid or dotted lane line should be based on several factors, including the speed and volume of turning vehicles, the presence of bus stops and the frequency of that transit use, and the types of vehicles that may cross or enter the bike lane. At locations with infrequent conflicts, the bike lane should often remain solid up to the intersection. Dotted lane lines should be used to delineate conflict areas within the bike lane at locations where intersections are signalized and bicyclists and motorists operate concurrently, where right turn lanes are not provided and turning motorist volumes are high, and where buses frequently cross the bike lane at transit stops. The guide also discusses how to handle buffer markings approaching intersections, which are illustrated on this slide. The guide provides images and discussion on best practices for bike lane designs at locations where motorists have a shared through right turn lane or a right turn only lane. The images shown on the slide are for intersection approaches with limited space where a right turn lane is not required for motorists, but where there are relatively high right turn volumes, say more than 150 vehicles during the peak hour, or where there's an existing crash history. In these cases, the treatments discuss transitioning the conventional bike lane to a separated bike lane. Signal strategies for these types of conditions are also discussed in the guide. When right turn only lanes are provided for motorists, the MDG covers 5 possible configurations to address these conditions. Some of these scenarios will have multiple alternatives, so the guide provides designers with some context criteria to determine which treatment is most appropriate for their condition. For example, on this slide, 2 options are provided for locations where long right turn lanes for motorists are necessary. In these cases, designers have the option of transitioning the bike lane to a separated bike lane, or maintaining a conventional bike lane, but also considering whether an optional bike ramp is appropriate to allow an interested but concerned bicyclist to exit the bike lane to cross as a pedestrian. For each of the scenarios, markings and signage are discussed. Where tapers occur for bicyclists, the guidance will follow the taper discussion of Chapter 3 of the guide. Section 6.5.7 of the guide discusses intersection options where paved shoulders are present. There are some unique considerations for locations with shoulders due to the Ohio Revised Code's guidance in section 4511.44, which notes that the operator of a vehicle, streetcar, or trackless trolley about to enter or cross a highway from any place other than another roadway shall yield the right-of-way to all traffic approaching on the roadway to be entered or crossed. This means a bicyclist operating on a shoulder must always yield the right-of-way to all motorists, but these bicyclists may not be aware of these yielding requirements. In order to accommodate bicyclists along a paved shoulder and clearly communicate the right-of-way to all roadway users, designers may consider the following options. Option 1, mark and sign the roadway such that the bicyclists merge into the adjacent shared lane and use warning signs to remind bicyclists of their responsibility to yield when operating on a paved shoulder. Option 2 is to transition the shoulder to a bike lane approaching the intersection or driveway, in which case the normal roadway operations would apply. The guide provides illustrations of these 2 options, as well as an additional illustration for right turn only lanes and bypass lanes. When the paved shoulder is wide enough for a bicyclist to use, and bicyclists are expected, option 1, shown on the bottom half of this illustration, recommends the use of a custom warning sign reinforcing Ohio state law that bicyclists on the shoulder must yield. Option 2, shown on the top half of this illustration, shows the shoulder transitioning to a bike lane. Designers may provide a regulatory sign identifying turning vehicles yield to bikes on state and local roads to remind drivers to yield, and where right turn lanes are provided, the typical begin right turn lane, yield to bike sign should be used. This section option of developing a bike lane may be better for bicyclists and will be more intuitive to both drivers and bicyclists, as the right-of-way operations are the same as any other intersection with a bike lane or separated bike lane. Option 2 should be considered if roadway speeds are greater than 35 miles an hour. In addition, transitioning a paved shoulder to a separated bikeway at intersections may be desirable at locations near high-speed exit and entrance ramps to highways. It may also be considered along high-volume, high-speed rural arterial roadways with long deceleration and right turn lanes, which are conditions where on-street bike lanes are not a preferred treatment. The final subsection that we wanted to highlight is for driveways and alley crossings. As shown on the table on the slide, guidance is provided in the MDG for recommended pavement markings, bikeway elevations, and driveway design treatments based on the number of motor vehicles using the driveway. When on-street bike lanes cross driveways, the bike lane may be continued with a solid white line if driveway volumes are low, and bikeway crossing markings should be used at higher volume driveways. The goal of the guidance in this table is to reinforce the right-of-way operations as well as the slow speeds of turning motorists as they cross the bikeway. The MDG also provides additional details for separated bike lanes, side paths, and corridors where on-street parking is present, as well as locations where driveways are closely spaced. As a reminder, the earlier sections of Chapter 6 covering bicycle facility design and bicycle routes are covered in the 6th module of this training series. In addition to the sections we discussed, there are sections in the MDG covering raised bike lanes, counterflow bike lanes, and bike boulevard designs for intersections and crossings. This chapter also includes guidance for grade-separated crossings, both over and under a roadway, as well as accommodating bicyclists in work zones. Thank you for watching this video covering Part 2 of Chapter 6 of the MDG. For other chapters, please see the additional videos in this training series.